Xbox admits that Game Pass is too expensive. They raised the prices of Surface systems by $500. DLSS Enabler enables 5x and 6x multi-frame gen to 40 series GPUs. Nvidia denies being about to acquire an unnamed PC maker. And we've seen leaks about a 9GB 5060 and 5060 Ti get debunked by another leaker, so neither one's official. We've seen that Nvidia has started to use AI as part of their GPU design process and has sped up efficiency. But we're also seeing that alongside reports of a 1,000% increase in warranty claims. But careful how you interpret that. Nvidia's revenue has also increased. So does that actually mean that the GPUs have become less reliable on average? More on that in a minute. Now, I also have review access to Pragmata. However, I need to be careful how much benchmark information I give right now because there's a different review embargo for platform comparisons than there is for reviews. Also, on the Pragmata note, we have a system requirements chart for path tracing in Pragmata published by Nvidia, alongside their announcement of their Pragmata game bundle, which is with 5070 or up laptop GPUs or desktop GPUs. Notice that 5050 and 5060 class products do not get the Pragmata game bundle. Now, let's talk about this, and then I'll say as much as I can regarding the performance of cards like, let's say, the 5060 Ti with path tracing. So, Nvidia has announced that the path tracing minimum GPU for the game should be a 5060 Ti. And if you want a recommended path tracing GPU, you should have a 5070 Ti or a 5080 for the ultra path tracing experience. They also mentioned some other system specs. However, they're not giving us, as far as I can tell, any performance information or even a monitor resolution target, although they do mention that they're using DLSS 4. Now, can I say anything about that? Well, Nvidia is saying that a 5090 can do 4K 280 FPS, although I can definitely tell you that's using at least ×4 frame gen and probably performance mode upscaling. Now, I have tested it on a 5090. Can I show you that? I've tested it on a 5070 Ti and a 5060 Ti and some other GPUs and from AMD. And I have determined by my reading of the embargo that I cannot give you a full detailed performance breakdown at a whole bunch of different graphic settings because my understanding is that that falls under platform comparisons. However, I am able to give you my review of the game, and maybe I could use some supporting PC performance numbers as just supporting my review of the game, and the detailed benchmark data will wait until Thursday. How's that sound? I've also seen other outlets, Capcom, if you're watching me, like Digital Foundry, for example, do something similar, where they did show some limited benchmark data, but will be holding off on their full detailed reviews until this embargo lifts. So let me give you guys my Pragmata review. Now, I'll mention I haven't actually completely finished the game because I've spent a lot of my time with review access to the game going over benchmark data, which full benchmark data coming on Thursday. However, I've played a large portion of the game and I really, really like it. Like, legitimately honest review of the game. It is good. It is... I like the combat style where I'm kind of bored of a lot of just generic third-person shooter games. This mixes it up with that puzzle-solving element to the hacking as part of the combat. Just adds a unique wrinkle where somebody who's old like me and has played so many games, honestly, a lot of games I'm just bored to tears, not because they're bad, but because they don't do anything different. This has enough of a unique twist to the combat that I enjoy it. There's a lot of upgrades to unlock. The level design is good. The graphics support the gameplay. I like the banter between the characters. And just overall, I think it's a very good game. I haven't quite finished it yet, but I absolutely plan on it. And for me, honestly, most games I start when I'm testing them, I don't end up finishing because I'm just bored. This is absolutely a game I plan on finishing as soon as possible. Really enjoy the game. Now, while I'm not giving you a full detailed platform comparison, as a PC reviewer, I think I should also talk a little bit about my experience playing the game on a mid-range GPU like the, let's say, 5060 Ti 16GB version. And first, I tried out the game's default maximum preset at 1080p, which is what we're seeing here. And I had a very good experience in the early parts of the game, which are closed in, and that's kind of what you're seeing here. So this is called the quality preset. There's individual settings that you could turn higher manually, but it's the maximum preset for the game. Now, I did notice that this preset, which includes ray tracing, can have a little bit of visual noise. You'll see this once I start moving again in some of the ray traced reflections, but overall performance is high, and you can turn off the ray traced reflections, which loses you some reflections, and there's a lot of reflective surfaces, but it does reduce the noisiness. So if you're somebody who's like me and you're bothered by the noise, you might want to either turn off ray tracing or enable path tracing. Now, as I turn the corner here, you'll notice there's, again, a lot of noise in the ray tracing on this grading here, but also notice that performance is dipping. We were averaging like 120 FPS previously. This is native 1080p on the max preset. But now that I'm in this more open environment, which wasn't featured in the game's demo, so performance has dropped into the upper 80s. Now we're back over 90. So performance is still very solid at native maximum default preset on a mid-range GPU. So that's in support of my positive review of the game, not detailed platform comparison. Now, because I was bothered and it was actually affecting my gameplay, so this is part of my review, I was bothered by the visual noise. I did try turning on the path tracing mode just to see if it would stop distracting me with that visual noise. So this was still on a 1080p display, but I did have to enable DLSS balanced mode to get performance I was happy with, which is what you're seeing here. Now you'll notice that the overall image does look soft because of the low internal rendering resolution at DLSS balanced, but you'll notice there's no visual noise in the reflections here now. So it has solved the noise problem. Although when I stand still and look at a wall or something, there can still be a little bit of boiling in the path tracing mode at lower rendering resolutions. Also, a lot of the visual noise in this area is gone as well. So path tracing gives us a lot more reflections, more detailed reflections, and it reduces that visual noise, which was affecting my gameplay, which is why this is part of my gameplay review on the PC platform rather than a detailed platform comparison, which won't come until Thursday, Capcom. So be clear what I'm doing right now. This is part of my review, not my platform comparison. Now, notice that in the more open area, though, my performance has dropped into the mid-50s now at 1080p DLSS balanced, but I'm still pretty close to 60 FPS. Personally, as my gameplay, to enjoy the gameplay experience, because it's my review, not my platform comparison, I turned on ×2 frame gen, and I found that it actually smoothed things out pretty well. For the most part, the baseline performance was high enough that latency felt good, the game felt responsive, and I did feel like it was a good frame generation implementation. So I found playing the game at 1080p DLSS balanced with ×2 frame gen, the footage I'm showing you here doesn't have the frame gen enabled, was a pretty good gameplay experience. So I was able to enjoy the game, and overall, the performance didn't impact my enjoyment of the game on the PC platform. However, on a 1440p monitor, which many gamers would be using, and I used for some of my gameplay as well, performance was a little bit harder. So here I had to rely on DLSS performance mode to keep the path tracing around 60 FPS on a 1440p display. So it does look a little bit soft, but again, there's not like the visual noise that we get when we have the path tracing turned off. However, some areas of the game are in more open environments, and so my gameplay experience, which I'm reviewing right now, not the performance of the game, my gameplay experience was somewhat noticeably worse when playing with path tracing enabled, even at DLSS performance, because my performance did drop into the upper to mid 40 FPS range in these more open environments. So my enjoyment of the gameplay, which I'm reviewing here right now, not the performance, did dip a little bit, although ×2 frame gen did generally kind of save the day on that, and I actually still liked this experience. Although some people may enjoy the game more, which is what I'm reviewing right now, by just using the maximum non-path traced settings at 1440p native resolution, because those people might enjoy the sharper visuals because we're at the higher resolution, although, and also actually higher performance, even though we're at native resolution here, because we've turned off path tracing, although there is a bit of visual noise. Now, I noticed that there's less noise at 1440p than there was at 1080p, and even at 4K, there's even less noise. So the more rays you get, the less noisy it is, which is part of my enjoyment of the game, which is what I'm reviewing right now. Anyway, and you can see there's a bit of noise here, which affected my immersion of the game a little bit as well. Now you can see in the open areas at native max settings, non-path tracing, 1440p, I was still at mostly over 60 FPS. And like I said, ×2 frame gen works pretty well from that baseline to enjoy myself on a high refresh rate display. So I think that's all I can say about my enjoyment of the game. My performance review will happen on Thursday. This was all just talking about my enjoyment of the game as it was impacted by various certain settings, but much more to come in my platform comparison. Okay, guys? I think I've got myself okay on following the review embargo here. Now, let's follow up on some of those other stories. One of the stories I mentioned at the beginning of today's video is that warrantyweek.com, all my sources, by the way, will be linked in the video description, warrantyweek.com, which I'll admit to being not familiar with. I've seen various news sources and Reddit threads, etc., referring to this, so that's where I found it. Is mentioning that Nvidia's warranty claims increased by 1,000% from 2024 to 2025, while AMD's also increased, but only by 116%, which is still a pretty big jump. Now, I've seen many comments and even some news articles trying to imply that this means that NVIDIA GPU's quality control has, bottomed out, and that this is evidence of that. But as a math teacher who sometimes teaches some basic statistics, I should also mention that you need to consider other things that have also increased that could be potentially explaining this. So I'm not trying to just be an NVIDIA defender right now. I'm just trying to be a responsible interpreter of news. Also, we should say, where are they even getting this information from? They're saying they got it from the annual reports and quarterly financial statements from NVIDIA Corp and AMD, where they gathered three key warranty metrics: the amount of claims paid, the amount of accruals made, that's a hard word to say, accruals, there we go, and the end balance of the warranty reserve fund. So then you get this chart, which is making the rounds on tech media and tech forums, etc., where you see that the warranty claims from NVIDIA jumped like astronomically, and then you get the claim that this means that NVIDIA's GPU quality control has been terrible since the 50 series launched. Now, there's corroborating evidence. We've seen lots of claims about melting cable connectors, missing ROPs, NVIDIA drivers haven't been what they used to be. So I absolutely agree that there has been some evidence of a slip in certain quality control elements for NVIDIA GPUs after the 50 series launched compared to previously. There's lots of anecdotal evidence of that. And so it is absolutely reasonable that there could have been some increase in warranty claims based on that. But I do not think that that makes sense for a 1,000% increase in warranty claims. I think what makes a much better explanation for that, I should have warned you about the flashbang before doing it, but here you go. This is a different chart, this coming from AppEconomyInsights.com. But this is based on also NVIDIA's publicly available revenue information. By the way, they're quoting fiscal year results here. Fiscal year, not the same thing as calendar year. So fiscal year quarter 2 2026 is actually like end of 2025 by the calendar year as I understand it. So in other words, when we're looking at the switch over from 2024 to 2025 here by revenue, we should be looking more at like the switch over from here to like here, some chunk in there. And what you'll notice is there has been massive increases in revenue, especially in data center. It's also unclear exactly how data center factors into warranty claims, because that doesn't seem to be separated out here in any way that I can tell. So what I can see, again, flashbang, is that a large portion of the sheer dollar amount of warranty increases is likely explained by just NVIDIA selling more product. So in other words, if your sales go up 10x and your warranty claims go up 10x, when both are just measured in dollars, you probably have the same quality control level. Whereas if sales go up less than 10x, but warranty claims go up 10x, that's where you could see that there's some other things also explaining some of the warranty claims. Now, it's hard to break this down, so I'll just say that it stands to reason, based on anecdotal evidence, that some NVIDIA quality control hasn't seemed as good with the 50 series as it did with previous generations. Like I said, there's been more reports of driver issues, there were the missing ROPs, there's been some melting cables, but I don't think any of that on its own explains a 10x increase in warranty claims. Also, AMD saw a 100% increase. AMD's revenue has also gone up, not as much as NVIDIA, but they have also benefited from the data center boom and AI boom. So with all of that being said, I think this is interesting, but don't go completely wild with what it means. And like I said at the intro of the video, there have been some people even citing this article as AI is just designing NVIDIA GPUs now, and that's why there's the lack of quality control. Well, this is actually just an interesting article, and I can't at all comment on whether this is factoring into any sort of quality control issue that we've seen on NVIDIA GPUs. Like I said, I think the better explainer is just the overall revenue increase. Now, this is still a really interesting thing, so I think we should take a look. So I found this at videocards.com. All sources will be in the video description. NVIDIA says AI cuts chip design work from 80 person months to overnight on one GPU. Now, it's important to get the details because I don't think it's all of the chip design in general. It's a specific element of it. So let's read the direct quote from Bill Dally, who is NVIDIA's chief scientist. Direct quote. So we're trying to use AI wherever we can in our design process. And there are a number of examples. For example, every time we have a new semiconductor process, we have to port our standard cell library to it. It's about 2,500 to 3,000 cells, and that used to take a team of 8 people about 10 months, so 80 person months. Then we developed a program based on reinforcement learning called NB-Cell. I think we're up to NB-Cell 2 or 3 now, and it's overnight on one GPU. The results are actually better than the human designs in measures such as cell size, power dissipation, and delay. It matches or exceeds the human designs. It's a huge productivity gain, and it eliminates an obstacle to moving to new processes, because now we can move cell libraries over very quickly. So a more accurate headline would be NVIDIA says AI cuts moving cell libraries from one node to another to overnight, from what used to take 10 months for a team of 8 people to do. Now that sounds like a huge speed up, and they claim by their own metrics, and I have no data available to try to analyze their claims, that it is as good or better than the human results. Now, I don't think this means that NVIDIA can literally just jump from one node to another process node overnight, because this is just talking about cell libraries. And my understanding, which admittedly is limited, I am a math teacher and part-time tech YouTuber. I am not a GPU designer or engineer. But my understanding is there is more to jumping a process node than just moving the cell libraries over. So this seems like it removes one huge bottleneck to that process, which used to basically mean you couldn't do it faster than 10 months because it took 10 months to do that part. So even if you sped up other processes, you can only move nodes as fast as the slowest part of moving nodes. You can't move the node any faster than the slowest piece. So this piece, which used to take 10 months, is now basically just no longer a bottleneck. Cool. I think there's still some other bottlenecks that do take longer than one night on one GPU. Still very interesting though. Now, another big news topic I've been seeing blowing up is, are we about to get 9 gigabyte versions of the 5060 and 5060 Ti? We had previously seen rumors of a 5050 9 gigabyte. Now, videocards.com was running this based on a board channels post where one of their moderators had said that this was happening now for the 5060 and 5060 Ti. However, the Megasize GPU, who does have a pretty good track record, is now saying that there is no plan for that, but the 5050 9 gigabyte is still on track. For those of you confused about how you could move from 8 gigabytes to 9 gigabytes on the same GPU design, it has to do with moving to 3 gigabyte modules instead of 2 gigabyte modules, and potentially playing around with the bus width of the GPU as well. Because moving from 2 gigabytes to 3 gigabyte modules would give you a 50% increase in memory, so you'd go from 8 to 12. You would have to mess with the bus width to also change the number of modules in order to arrive at the 9 figure. The reason that that could be an issue on cards like the 5060 and 5060 Ti, to my understanding, is that those cards already use GDDR7. So you would lower the bus width and keep around, and so you would lower the overall memory bandwidth. So the cards would actually have worse performance despite gaining 1 gigabyte of VRAM. Whereas with the 5050, that's not as big of a problem, because the 5050 currently on the desktop version only uses GDDR6X. Or it might be 6 or 6X. The point is, it's not GDDR7. So if you, on the 5050, reduce the bus width, but you move to GDDR7 at a much higher speed, you can actually overall match or exceed the previous memory bandwidth while also gaining 1 gigabyte of VRAM. And that's why the 5050 makes so much more sense to do this than the 5060 or the 5060 Ti. So I still could see this happening. NVIDIA absolutely has released GPUs with the same name, but different performance and different memory bandwidth. So I don't think it's the case that NVIDIA would be scared of doing that. They've done things like that before, but that's why it makes more sense to do it on the 5050 than those other cards. Anyway, Megasize GPU, leaker, not official source of information, has leaked things in the past that imply that he has some access to or is himself within an AIB manufacturer based on the type of leaks that he has accurately leaked in the past ahead of time. Board channels also seem to have some access to people within, well, board channels, meaning board partners. So they've got some things right in the past. Megasize GPU has got some things right in the past. Both of them seem to have some information within board partner channels. And they have conflicting claims here. So I'll leave it to you as to what you want to believe. I'm just reporting. Now, NVIDIA has denied a rumor of acquiring an unnamed PC maker. This had been so followed yesterday that Dell stock actually shot up 6% and HP shot up 5% because they were rumored as the targets for an NVIDIA acquisition. And that drove up stock prices. Now, NVIDIA has now told CNBC that that media report is false. NVIDIA is not engaged in discussions to acquire any PC maker. I had had my doubts when I had heard about this, when people were saying, like, NVIDIA to acquire Dell. Dell is huge. Like, I understand that NVIDIA is bigger, but, like, Dell, like, yearly revenue is very large. They're absolutely massive. It would be a very major acquisition if Nvidia were to acquire Dell. So I don't know, guys. I don't know where the rumor came from, but Nvidia has officially denied it. Now, whether there's any thoughts behind the scenes still happening, who knows? I don't know. Don't know where the rumor came from in the first place. Now, DLSS Enabler is an interesting tool that has now added a version of x5 and x6 multi-frame gen for 40 series GPUs, but it's not really DLSS multi-frame gen. So I haven't actually tried this tool out myself, but I have researched what it's doing. Maybe I'll do a dedicated video where I actually test this out and benchmark it and all that. But to the best of my understanding, it's doing something along the lines of using AMD's frame generation, using DLSS inputs, and I've seen conflicting information about whether it's actually providing better quality than AMD's frame generation by doing some sort of a DP4A improvement, and or like somehow using more of the DLSS code in there. I don't know, guys. I'm gonna say that this is something I need to research a little bit more myself before I feel like I have definitive answers on exactly what it's doing, but I'll just report it as an interesting tool that you might want to play around with that I have not yet tried personally, and I will link this source in the video description. Now, a couple just quick notes at the end. Microsoft has revealed major price increases for all Surface PCs, blaming the RAM and memory crisis. Flagships are now $500 more expensive than at launch. And the source here is Windows Central, will be linked in the video description. And Xbox Game Pass has become too expensive, says Microsoft's new gaming chief in leaked memo. This coming from The Verge. Source will also be in the video description. My kids, I just heard come in the door on their way home from school. I usually film these videos because I get home before they do because I have zero commute time. So anyway, they're here. I'll just wrap up these stories quickly. Sources in the video description. Wait for my full platform comparisons on Pragmata until Thursday. I hope all of you have an excellent day.